Okay, welcome everybody. Can everyone hear me? Okay, great. All right, welcome back. Let me make sure we're recording. I believe we are. Kind of looks like it. All right. Okay, so we'll start off. While we were beginning, I had the next assignment. I'm going to talk about that towards the end, and we'll get into that just before that, before we do the demo. So this should read assignment 1B, and we're gonna, well, that's last class. We did the 3D game, chapter 3 game for frameworks, the elemental tetrad and the inscribed tetrad with the 3 layers. So make sure you read up on that stuff. I also graded a bunch of assignments over the weekend, and so I'll be answering that. Generally, I would say about like 95% of the class, both classes sections did well. You actually read everything and followed the instructions. If you got like less than the full amount, it's probably because you didn't read the full instructions and you didn't do what I wanted. I'll give you a chance to resubmit for half the points that you missed, and we'll take it from there. And then one more person coming in through the waiting room. So that's okay, that's good. And then quite a few of you are asking for the recordings to be posted. And there was a little incident in one of my classes last week. So I'm holding off on posting the recordings, and I'm going to change my policies on the recordings. The recordings will go up within 1 week of the date. It's not going to be an instantaneous type of thing. I'm going to try to get to it within a day or two, but unfortunately, can't always do that. And I also want to remind everyone about etiquette while here in this this shared environment that we're in. I would like everyone to basically unmute yourself as much as possible and unmute your video also, but be mindful of what goes on around you in your video. Make sure it's appropriate. This basically is a classroom. Virtual does not really matter. You know, we're all in this together, and this is what we have to do to get through this. So I want to make sure that you remember that if you are at school or on campus, you are at school. If you're on campus, you have to follow the rules, and it's no different here. So please try to be respectful. Try to be mindful of your fellow students. Help them out if you can. That would be great. All right. Before we get started, does anyone have any questions or want to ask anything? If you have a question, please use the chat room or just unmute yourself and start chatting and talking. That's generally better. It's kind of hard. I'm on a smaller, reduced window footprint to try to get better bandwidth, conserve the bandwidth that we have going out. Hopefully I'll be able to manage all of that together. So I'll pause for just about 10 seconds. If you have a question, now's the time to either raise your hand or let me know. Alrighty, let's get back to the sharing. So I'm going to share the entire screen and stuff will pop up on there as it occurs. All right, and as always, if you see somebody in the waiting room or if I start to freeze, please let me know. Tonight we're going to be going over assignment 1B, Eureka, and GitLab Unity Progress for Organization. And we will also be talking about something called a game loop. This is fundamental to all game engines that are in there. There's less emphasis on it nowadays, but it's still there, and you need to understand about the game loop so that you can write more performant code and make your games play better, basically. All right, I'm going to skip over the stuff from last time. We did Unity folder organization and stuff. We'll get to that after the game loop stuff. And I had some recommendations on there. So I want to draw your attention to this picture here. And I want you to think about what goes on when you're playing a video game. So this is a very crude picture representing the flow, if you will, of the processing that's happening on a computer playing a video game with a person playing there. It doesn't matter where you start out with it, but we'll start out on the left. And we have this process input area where basically this is a large block of code that basically takes input in from the user, whether it be like a keyboard or game controller or some kind of like handheld item or something, and it processes it, and then it makes a decision based on what to do. And then it goes into this update game section. Now the update game section may happen several times, and that's why we've got this feedback loop over here with this little clock up there. And then once it's done updating the game has to put out, if you will, its final things. And this is where it draws the stuff on the screen that we're seeing. And that's referred to as the render cycle or the render part of it that goes on. And once it renders stuff, the program is just a while loop. It goes back to processing input and it starts all over again. Any questions about that? Seems pretty straightforward. Okay, where'd my chat window go? Don't know where my chat window is. This is annoying.
As professor, just to make sure I'm not overthinking this too hard, the clock timer there, I'm assuming is just the system clock, and I'm assuming that output for the system clock and the render happen at the exact same time.
Well, not really, because they happen sequentially on our modern computing systems. We don't have the quantum massively parallel computer. Now, there is stuff that's happening on other GPUs, and the image that you see here is a little bit more complicated. So this one we took from the Games Workshop section, and here's another one that shows you some of the stuff that goes on in here. And maybe this answers a little bit more of your question about, okay, there we go. I'm gonna move the chat window off so I can see it better. So essentially, those three boxes that were laid out horizontally, we've stacked them vertically and just drawn them a little bit differently. And we're starting to make like little sections around them. But the idea is pretty much the same. You have a loop going on where you get input, you process it, you update the game world, and then you render it. And then you go back to the top of that and you go in there. And oftentimes we think of this as happening with like a certain number of frames per second, 60 FPS has been the current standard for some time now. But we're going way beyond that with the technologies that we have now. On the right-hand side of it, um, yeah, well, they're coming, Robin. Be patient. So, with the stuff that's happening on the right, what we're doing is we are just basically um, unpacking, if you will, the update loop that's drawn over there on the left-hand side. And when you start thinking about your game, there's more stuff that happens than just update and render, update render. What really happens is your game actually initializes. And if you've played any Steam games, you know that when you really want to play, you hit the play button and it's going to be like loading assets, checking for updates. That's really what's going on up here in this init and preload thing. And then your game has to set things up. And we talked about like, in the frameworks where like the artwork, it's at that, that static inscribed level. And then it's different when you play the game. And, there's a lot of stuff that goes on. And I'll demonstrate some of that a little bit in the Unity demos. But yeah, we think of our artwork as being like cool stuff like PNGs or a nice, Blender 3D model or stuff like something like that. Maybe it's a really cool music, like I play on the intros while you're waiting in the wait room. But in the reality is, inside a game, those media files, those art files, are actually represented in a more optimized way for the internal workings of the game itself. We don't sling around whole, PNGs. We sling around highly optimized texture files and 2D arrays of basically numbers that represent the colors inside of an image that we have there. We also, have like these very complicated 3D models, and those are broken down and chopped up and stored in a way that it makes sense for the internal mechanisms, the internal GPUs to render. So a lot of that gets done in these preload and creates stages. So the reason why is so that this update render loop can go as smoothly as possible. It can happen as quickly as we need it to have happen. And then furthermore, when you are done playing, you have to shut down. So that's where it kind of undoes all the create, preload, and the init stuff. So there's very definite stuff like that. Maybe there's a saving of a game state in there. Maybe there's like updating something on the cloud or something. Any questions about that? No, it's pretty straightforward. Now, this is, I put this in here just to harken back to the old XNA game engine that we used to use for this class. Same thing. They kind of all look the same. You got an initialize section. You do something with the content. You preload, and then you go into this while loop where you update and draw, update and draw. If there's a game over thing, you exit the loop and you unload the content and you quit out of the game. Pattern's pretty much the same. Sometimes they draw it a little bit different, but you get the idea. Now, Unity does this slightly different. And it's kind of more like this drawing over here on the right-hand side of the screen with the init preload create. That's why I chose that. So we're going to go into it. There are certain functions that you need to know about, and you need to understand how they operate, because in the understanding of it will help you build a better game. So Unity is very complex underneath the hood, and we're going to talk a little bit about that tonight. But there's a bunch of functions that I want you to know and to play around with a little later on. So starting off, there's something called awake. And this function is called before anything starts up. It's also called after a prefab is instantiated. It can be thought of as like initialization type of routine, but it's not like what you would think with a class being initialized. There's already classes that your game will inherit from, and they've been already initialized way before we get to this section of code that your game object is going to be putting out. So we have that. And basically, this happens when the scene and the project loads. This also happens, there's a clear distinction in Unity in code that is running inside of the editor and code that is running as a game. They're two different animals, if you will. There's two different engines. They do follow the same patterns, and they have the same calling order that the functions are called in. So next, we have this function called onEnable. And this function is called just after the object is enabled. When you instantiate an object, this is called kind of like when there is a level that has been loaded and the script has been initialized or instantiated, I should say. And you can do this inside of the Unity editor just by checking and unchecking a little checkbox next to the game object that whether or not it is enabled or not. And it basically is like, hey, is this game object ready for use inside a game? All right, then we get into an update part, and the update part is broken out into several subparts. So there's an update part that keeps track of the game logic, animations, interactions, camera positions. Those are usually called inside of there, and there are a few different events that you can use. Most common pattern is to perform most tasks inside of the update function, but there is one big thing that we don't put in there, and that's anything that has to do with physics. If you're trying to update something, a game object, that relies on physics working correctly, then you do it in a different update function. You do it in the fixed update function. And I think of like physics, pH, F sound starts with an F, fixed update goes for that one. So that's a little mnemonic that I use inside of there. Generally you do most of your stuff in update, except if, of course, if it has to do with physics, such as a bullet or something falling. Physics like making your character jump, yes. But there is more than one way to make a character move. And we'll talk about that probably tomorrow. So basically you'll get the inputs in there, but you might update them in fixed update to have smooth motion. And the reason why we do this is what I said, smooth motion. If you update in the update function, you may notice a jagged type of movement. If you're supposed to have like a pong ball going back and forth across the screen, and you're doing your updates in the update function, you may see it jump or stagger as it goes across because the time between frames isn't fixed. That's an important constant to know. And so you need to know how much time has passed between one frame to another frame. And it turns out not all the same amount of processing happens between frames. There's all sorts of stuff going on in the background that Unity has to tend to. So like your first frame may happen at like, let's say 100 milliseconds. And then your second frame may happen at like 130 milliseconds. Your third frame at 180 milliseconds. So those times between frames 2 and 3 are not equal. But Unity does keep track of it. There's a little tiny clock inside that we can access called time.delta time. And time.delta time is the change in time between frames. And you can use that to calculate like, you know, the amount of movement that your character should have done in the time that has gone on since the last frame. Okay, and this will become more clear as you start working with it. So I'll get on with that. So then let's see, there's update. Update is called once per frame. And then there's late update, which is also called once per frame, but it's later on in the cycle, as the name implies. And it's after update has finished. And this is another opportunity for you to do calculations, also to like update things like a camera that's following a third person character. They may jump, and then you may want to position the camera behind the character after they jump. And the opportunity to do that is after all of this code gets executed. And I have a graphics that I'll show you that'll do this. And then finally, there's two other functions that are really cool. There's on GUI. This is where a lot of real-time GUI stuff gets called. We're not going to do it at this point. We're going to use a different GUI mechanism called a canvas GUI to work with it. There's an opportunity in there to render GUI stuff. So this is where you can repaint stuff and you can do like HUDs and overlays and stuff like that on top of it. And then there's another really cool one called on-draw gizmos. There's something called a gizmo mechanism, if you will, inside of Unity. And this is a little tiny graphical object that is drawn inside of a scene view for visualization purposes while the editor is running. Usually the gizmos are not drawn in the game. And a gizmo, you've seen it, and I'll show it to you. They're like the little things that tell you, when you grab an object and move it around. They're the arrows that come up on an object. So when you instantiate one in there. So we'll do that in a little bit. Now, what does this look like? Here's some code. We'll demonstrate it in a little bit. But this is very simple behavior. I've got a simple script. I've changed the formatting for it to fit all in one area. So here we have the script, and it calls the 5 functions that you need to be familiar with, and just outputs to the console something that you see there. And what you'll see is when you run, if you create a script, attach this to it, and run it, you will see these things being instantiated, and you'll see how often they get instantiated as your game is running. Make sense to you? Okay, good. All right, now, behind the scenes, Unity is a lot more complicated. So there is this big, huge, long list, and this comes straight from the Unity documentation. If you open up the Unity documentation and you type in game loop and event processing, this is the image in the section that it takes you to. And there's 24 functions that are described in here. But these are basically the large scale stuff that we were talking about in those hand-drawn representations at the beginning of the slides. It's broken out. We have like our initialization section at the top. We have our physics section. We have the input section where you get stuff in from there. You have your game logic in the middle. And each of the boxes that you see in there that kind of looks like a flow chart is a function that is provided by Unity by the mono game object, mono behavior object. And you are encouraged to use that and overload it in your code to do whatever it is you need your game object to do. So we have the game logic stuff, and then we spit it out, or their scene rendering part of it where it goes in there. Then we have some of the final cleanup type stuff. There's the gizmo rendering, the GUI rendering, the on GUI stuff, the late yielding. Then finally, we get through a frame. The end of frame thing is here near the bottom. And then mostly it goes back from this section here, goes back up to the top to this blue part over here, and then starts going through and, cycling through each of these functions as it goes along. So we'll talk a little bit about each of these and I'll highlight the things that you need to know. Okay. So starting at the top, here we have the awake function, and I've got a little blue oval here to highlight the ones that you need to know and understand and pay attention to. So there's the awake function. That's the first thing that it starts off with. And then there's the on enable, and then that goes through, and then there's the start function. The start function is called once for any given script, and it's before all of this goes on through there. It's basically still in the initialization part of it, but it's a little bit different. There's on awake and on enable, and sometimes you can turn on and off a game object in code depending on if you need to have it visible or if you need to interact with it, and that's why it's separated out in that manner. Any questions on those so far? Okay, so moving on to the physics portion of this. So inside the physics portion, we start with the fixed update section. And that's where you'll be doing your update of your character. As they leap along, you'll be calculating how far they should be leaping, and you'll be putting that in there. And then there's a bunch of internal stuff that Unity does along the way, and we generally don't mess around with that. But there are things that it's doing in there that can slow down the number of frames that are in there. It's like, for instance, if there's if your character or your object has some sort of animation that it's doing, Unity goes through the on animator inverse kinematic section, and it's calculating stuff based on what the animation is driving it to do. So it could be if you have a walking animation and you've turned on inverse kinematics, every time your character goes through the step portion of it, that will move the character just so much, and Unity is calculating it in that little section right up there. And this is why sometimes a frame can take more time versus another frame to go through. Now, towards the bottom of the physics section, there's two special ones that I didn't talk about, but you are going to want to learn how to code and write scripts for. Excuse me. There's the on trigger and it's XXX, and on collision XXX. And there's actually more than one. That's what the extra X's stand for there. So there's like an on trigger enter and an on collision enter function. There's an on trigger leave and on trigger leave, and and on collision, and on trigger while it's inside of there. So there's a couple functions for like when it encounters and goes into a trigger, as it's moving through a trigger, and then finally when it leaves the trigger. And also for collider, there's exactly the same thing. Triggers and colliders are very similar. When you first come into a collider, there's a function, an event, if you will, that gets raised for that. There's an event while you're processing through the collider, and then when you leave the collider, there's another event that gets thrown in there that you have the opportunity to write code for. Then there's also this yield wait for fixed update. We'll talk more about yields in just a second. The yields are really cool and they're very important. Okay, now as we go through, we have just finished the physics section of that big long flow chart that we have. We're coming right up into the input events and the game logic section, if you will, of this. So there is some mouse stuff that happens that's separate from update. You can also check the mouse and the update function there. So that's why I highlighted the update function. There's the update, so where you can go in there and you can check for, like keyboard things. Are they pressing the WASD key? Is the mouse button, being smashed on, or what's going on? You can check for that at that. There's also the yield sections in there that have the coroutines in there. And these are, essentially prescribed pauses. You can pause either for a fixed amount of time, and there's other pauses for like frames, and you can do a bunch of tricky stuff. Generally, it's you're waiting for a certain number of things or an event. This is also where they have the yield for a web hook, if you will. If you make a call out to an API, you have to wait for the HTTP request to be completed. That's where the yield goes, and it checks inside of there. And then finally, you have an internal animation update where Unity is still doing more animations, and it's processing everything in there. So it's figuring out what it can do, and there's a couple little loops inside of there. So those are going on inside, the loop that's inside of there. And then finally, we get to the late update section at the bottom. This is after Unity has done all of its game logic type processing. You have an opportunity to code in the late update section of it. And then that flows down into the next section. If you have any questions, just go ahead and ask. I included late update there. Then there's the rendering thing. And this is the graphics portion of it. There's the on-draw gizmos, and then the on-draw GUI, the GUI rendering stuff. This is mainly for real-time GUI functions. They usually are preceded with the on-GUI stuff. We're going to be using the Canvas GUI for doing our stuff, but that's up in there as well. And then a couple other, housekeeping type of things. Wait for the end of the frame, yield for that, pause. And then finally, we have the bottom of the loop where you can decommission it. You have, after it gets through all of the pause stuff, if you haven't explicitly told it to either quit the game or stop the editor, it will go back to the top. That's that black arrow that goes off to the right over here, and it'll start the whole loop all over again. If you do tell it to quit, it'll go through the decommissioning phase and then stop that. And then it goes back to checks to see if it's been enabled or not. What is a gizmo again? So gizmos are everything you see in the scene editor of the game IDE. So it's like the XYZ arrows. It's the lights that you see in there. It's basically like a little handle or an object to represent the 3D thing that's in there. So like if you have a spotlight inside of your scene, you'll see a little icon that looks like a spotlight in the direction that the light is shining. So that allows you to move it around and shine it where it needs to go. How the pause works again. So the pause basically is the check, but there's also the yield sections. Those are back up in here. And yeah, I'll be explaining how the yields go. There's a couple different yields that you can call inside of there. Unity checks for these inside of your code. You can check for like wait for a couple seconds. You can start a secondary coroutine that will go along in there. The takeaway message from all of this is I'm not going to grill you on the internal, I'll ask you what the definitions of these things are and when they apply, but I'm not going to, ask you like some, very detailed esoteric part of the internals of it. I need you to be aware of these functions and when the appropriate time to call them. Why do you use fix update instead of update? The answer is to get smooth motion. So those are the reasons, and that's the level of detail that I want you to go. And as always, if you want to know more about this, all of this came straight out of the Unity manual. You can literally go and read up pages on each of these functions, see what parameters they take, see the signatures, and get a better sense for understanding what's going on in there. Some of these you could actually even go look at the source code too, depending on how much you've signed up for or not. And some of them you can play around with, and we'll do that hopefully tonight.
Professor?
Yes, sir.
So is that whole loop all the way, or from the beginning of the loop to the pause, is that how, I guess, what determines the FPS of a game?
Yes. This whole loop here that you see up here, where it goes from the top of the physics gray box to the bottom of the pausing gray box, that whole big line there, how many times it goes through this is analogous to the frame rate or how many frames per second that you're getting.
Okay.
And just a little quiz to see if you guys are alive. What do you think the frame rate of Unity just sitting there is? You have nothing going on, you have a blank scene. What's your frame rate? Just take a guess. 30, 120, 30, 60. 60 is a safe answer. A lot of 60s and 30s. And does anyone know what the frame rate to see motion is? What's the minimal acceptable frame rate to see motion? 1. Smooth motion is what I mean, Robin. Couple people have got it. Dom got it first. Yeah, 24. And they actually did some experiments a while back. They had these things called film movie projectors, and they would take a bunch of drawings and put them onto a projector reel and flip book it, if you will. Like they would draw on a sheet of paper and then flip her like this, and they would play it back at 1 frame a second, 2 frames a second, and they would loop through it, and they realized that the human eye around 24 frames a second doesn't notice the gaps, if you will, the stopping and the starting, where it shines one picture, goes dark, and then takes the next frame and shines that. They determined that 24 was that's when you really start to see it. So the movie industry, way back in the 1900s, like 100 years ago, came out with 24 frames a second, and that's like the clickety clack sound that we're familiar with from a movie reel going in the background. Games, we immediately fixated on like 30 and 60 hertz because of the alternating currents that we use in North America. So we use about 60 hertz, 60 cycles per second. And so video games were centered around that. Unity just sitting there by itself does hundreds of frames per second. Which is absolutely amazing. And then if you have some simple motion or something going on in there, it does that. Isn't 60 the max of what we normally see? So I have to think about that, James. I think 60 is not the physiological max. Our eyes are analog processors. And so I think we see it a lot more than that. And I know like I definitely like my 144 hertz monitors. I perceive it to be a lot better than the 60 hertz LCD monitors. And some people are even saying, yeah, once you start using the higher hertz monitors, it's hard to go back, as Jesus points out. You definitely see it. And nowadays, we're seeing a convergence. Um, yeah, we're seeing a convergence in the big convergence between the gaming industry and the film industry, and in hardware that's manifesting as better flat screen TVs. So, like over the weekend, I was looking at some OLED screens at Fry's, or not Fry's, at Costco, and it was amazing. Um, how the quality of them, really beautiful stuff, and they're now starting to be semi-affordable. Um, you know, so it's interesting stuff. So yeah, and we'll measure that. Good question. So let's go back to the end, and we got to talk about the yield stuff. So, okay, coroutines. Um, yeah. So coroutines. Coroutine is a little function that gets called alongside that can run after the update function, and it could suspend its execution um, and until a given condition finishes. So it's called a coroutine, but it's a yield is mentally how to think about it. And it's really kind of weird. We're used to code running from the top down to the bottom in a procedural kind of way. And nowadays we have functional programming, which is just an amazing thing that's coming up. So all the async stuff that's happening with like JavaScript and some versions of Python, pretty cool stuff. And multi-threaded, multi-processor stuff, cool stuff. Unity doesn't really do that natively. It kind of fakes it with these things called coroutines. And there are still multiple threads going on, but it's not easy for normal programmers to access them in Unity. So we don't talk about them in introductory courses. But the way that you can make use of something that's close enough and actually very darn useful is by doing coroutines. Okay, so coroutines, there's different coroutines. So there's a yield coroutine that will continue after update functions have been called on the next frame. And then there's a yield wait for seconds coroutine that will have a specified time delay after all update functions have been called on the frame. So you can tell it to actually slow down and do something a little bit there. Then there's a couple more. There's wait for fixed update. So like if you need to wait for some sort of physics event to happen, you can use a yield wait for fixed update coroutine. Like say like if you want to check if something, I don't know, if you wanted to write your own collider, I guess. You didn't trust the Unity built-in colliders. You wanted to do something extra special. You can use that. There's the yield wait for a web coroutine, as I mentioned before. And then you can create your own coroutine to start your own coroutine that chains the coroutine to wait for another coroutine that usually has like a wait for seconds or wait for some sort of external condition to occur. And usually these are manifested in a game. Like one of the things that comes to mind is like a guard that is patrolling a certain area, sentry, if you will. And you're in the game world and you're coming up to the guard. And essentially, you don't want your non player characters to be hogging up all your valuable CPU time. So your player character is going through the game loop as fast as possible. But the NPCs that are the sentries up on the walls, or by a doorway or something like that, they don't need to check every single frame. They could check like one every 20 frames, or one every 10 seconds, to check to see if anyone has stepped into the zone that which is going to they're going to be activated in, and then they could start doing their thing. And that's one of the main reasons for using them. And there's others as well. Okay. So here's a little demo of a coroutine concept. This is like the idea that you want to like have like some sort of coroutine that does a fade function. Say like as you use something up, it fades away. So you'll think like, okay, well, I'll have like I'll have my render thing inside of there. I'll call the fade coroutine, and I'll change the color from like full color to like some other color based on time. And this seems like a good first start. But the reality is you don't want to do this type of coding type of thing. And the reason is because of that indeterminate time between frames. There's all that stuff that's happening that Unity is taking care of for us. So we don't write our coroutines in this manner. The way to write the coroutines is to have it return an IEnumerable, if you will. And an IEnumerable is basically something that can be iterated over. So here's an example of a coroutine in C. And it has pretty much all the stuff in there, except it's got one extra line down at the bottom. So it's going to decrease or decrement a floating point number from 1 to 0 over some amount of time. It's going to get the transforms and the colors in there, and it's going to set the alpha part of the color to be whatever's in that for loop, the ft variable in there. And so what that'll do is that'll slowly dial down the alpha part of the color for this material in there. The debug log spits out the value to it, and then we have the thing that makes it work. That last statement down there, the yield return null, that's basically the part that will pause for one frame and then go on. Now, this function will go from 0 to -1 in less than the blink of an eye, if you will. It goes too fast, if you will. So you'll use a different yield statement inside of there. And here's an example of some code which will yield a code up on it's waiting for a coroutine. So this will not kick off until you actually press the F key inside of there. Everybody press F and then B for brackies in the waiting room or in the chat room. Sad day. Sorry to see him go. But anyhow, that's how you do it up there. Okay. Any questions about these so far? No. And here's finally an example of the IEnumerator fade inside of there. Oops. Change my windows. And let me check the waiting room just to make sure. Okay, good. All right. So this one actually does the thing that we can see happening on the screen. So this has an IEnumerator as the return type. So it'll work as a coroutine. Same code as before. The only difference is that last line. It calls a yield return and then a new wait for seconds object, which will wait for a 1/10 of a second between there. So it'll go one frame and then hit that last line and say wait for a 1/10 of a second. The wait for 1/10 of a second function checks the time dot delta time. And if it's greater than the value passed into it, in this case, 1/10, it'll return, and then this will tick off again. It'll get to the end and it'll go around and check again for an entire frame. Does that make sense? Okay, almost done here. Then there's this idea of optimization. So sometimes you may need to include it in there when task doesn't need to be repeated. You could put a coroutine to get the update regularly, but not every single frame. So this is pretty much the same code as before, but it shows you that this is more of the optimized stuff for there. So instead of the yield return null, you used a wait for a second stuff that I had on the screen before. I guess it's a duplicate slide. It just says the same thing in a lot more detail. Okay, any questions about this? Okay, we got about 15 minutes left in class, and I did want to talk about two more things. A little dehydrated here. Okay, so next up, I want to talk about this, and I haven't posted this yet, but I want to get this in front of you guys, and want to talk about the next assignment that's out there. I'll be posting this to Blackboard right after the lecture tonight, and I'm going to give you about a week and a half to do this. And I'm trying to come up with some sort of incentivized thing. I don't like this idea of like releasing an assignment and then having to, wait for it to be due. So I'm trying to incentivize people to do it early. I just haven't hit on a good idea yet, so I'm not putting it up there. But basically, I'm asking you to continue on with our character generator. But this time, what we're going to do is we're going to create another project on Rieka, and this is going to be the skeleton or the shell of a game menu system that we'll be doing. So let me switch screens, and if you have any questions about this, go ahead and just unmute yourself and ask. And let me stop that. Find my browser window. Okay, so there's that. And let me make sure I have a version that you can download. It's coming at me. September 30th at midnight is when I want to make it due. Okay, so here it is. It's up on the Blackboard now. And I've created a link so that you guys can download it all. And basically, I'm breaking up my monolithic UI character generator from last year's class into different parts. So for the first part of this, you created a folder on Rieka, and that should be fine. Let me share my screen so you guys can see what we actually have going here. Um, okay, can you guys see it on the? Okay, all right. So for this part, what I want you to do is basically build a skeleton for a game. We're going to follow the same naming conventions, but it's going to be slightly different name. So for this one, I want you to create a folder, and I want it to be called pretty much the same thing, except it's going to end in project 1B. So it's this part right here. Okay. And you're going to build a UI and a menu system. And this is kind of like the basis for every game that you have. Every game has like buttons to like play a game, roll a character, quit the game, and maybe find out about what the game developers are, the game studio. So this is what we're going to do. You're going to have a UI that has a menu system. And it needs to be able to work in both the editor mode and as it plays in a running game. So it has to be able to quit a running game. You're going to have 5 buttons inside of there. You're going to have an about, settings, roll character, play game, and a quit. The roll character and the play game should be visible but not available or selectable. So those should be things that don't do anything, a no op kind of thing. The about, you can have it do an about page. The settings, you can start working on something that controls your game settings. And your play game should just go to a very simple scene, and there should be a back button from your play game. So that goes back to the menu, and from there you can quit the game. Couple things. Remember, you have to do all this code yourself, and it should be done in C# using Unity 2019.4. I think it's 1F is the version that we're the long-term release one. You must use Rieka to turn it in. It's on Blackboard so I can give you a grade for it. But all your code gets turned in via Rieka. Okay. You need to create or not initialize it with a README, and then have like your bibliography in the README section of it. When you do that, this will create a merge conflict. The basics, one of the basic lessons of this is how to resolve a merge conflict with a simple project in Unity. Okay, so let's move on to the rubric. Unless anyone has questions, now's the time to, oops, I just unmuted some random person. Sorry. Okay, so here's the rubric, 50 points. This is a very simple project. If you get started on it, you can bang this out in maybe an hour or so. It's not that complicated. There are some parts that you have to figure out, and I'll help you get through them, but you do need to do a little bit of work on that. So first of all, 10 points for all original art. If you create your own buttons and your own things, It's pretty darn easy. I'll show you how to do it. You'll get full marks for that. If you don't have any buttons and you don't have any code like that, you get no points. Simple as that. Folder organization. So you must organize your assets, and we'll talk some more about asset folder organization. Probably next class we'll lead in on that, since we're running out of time tonight. And then version control. You get 15 points for having good quality commits. They're frequent, they're well explained. What I'm not looking for is the typical, brilliant, inexperienced computer science student commit style. My son used to do this all the time. Basically, he would work on the project, and then at the last moment, he would put it under version control, and then you would get all the commits all at once. One big massive commit with all the code in there. That's not the idea that we want. That's not the reason why we're using version control. We want to start off putting it under version control, and make small little changes to it like every day as we code along, and then have progress towards the final goal. So yes, like draw your own buttons. And then you have to push it back to commit, or you have to commit it back, push it back to Rijeka, and I will know that it's ready for grading when you make a commit message with this particular message there. So Bashir, it's not just your own buttons, although that's all that's useful here. The next version of this, you're going to have the roll your own D&D character. You'll probably want to think about some background graphics, some graphics for different areas, for panes and stuff, those sorts of stuff. Questions so far? Yep. Kyle is the grader, yes. Is the art scored on how nice it is or just if it's an original? Well, it's if it's original. Yeah, I've been programming all of my adult life, and I've been doing graphics for most of it. And my drawings still look like crayons on like cardboard. So that's the quality. That's the standard that you have to rise to. It's better than my art, then yes. 2D. This is a 2D game. Should put that in there. Thank you for asking that question. I'll say 2D, 1D, 2D. So Natalia asked a very good question. Is it the same as the other project? No, it's very similar, a different name. Keep the blank one there. Okay, so James Lee asked the most important question of the evening. All right, James. Okay, so where to draw it? So there's a couple places to draw it and stuff, and it's related to folder organization. All right, James, are you asking where to put it or what program to use to draw it?
So I guess I know where we would import it in a sense, but I guess where would we draw it? Because I've never really drawn ever.
Okay, yeah. Normally a lot of people have heard of a program called Photoshop, and Photoshop is a great program. There's a Adobe program that we have for SDSU, and it's wonderful. But I don't think it's completely free. It might be free while you're at SDSU. Um, and that's a pretty good place to go while you're a student. But there's Photoshop alternatives. Uh, and let me bring this up on here.
Might I suggest Krita?
Yes, you may. So Krita is and so there's two alternatives that I suggest. And if you search a little bit, the first one somebody suggested is called Krita, krita.org, and they have a desktop thing. And then there's also the GIMP from which is the GNU package manager. So the GIMP is the incumbent, if you will. So the GIMP is the GNU image manipulation package. It's an open source project. It's very mature and it's been around for many years. And so it used to be considered like the only real alternative to Photoshop because nobody uses Paint after puberty. But Paint is still good. And then there's a new kid on the block called Krita. So Krita was introduced to me 2 semesters ago, and I've started playing around with it, and I'm kind of liking it. It's like a combination between Photoshop and I guess Illustrator. It has a steeper learning curve. All of these do, but these are the programs that I would suggest you start with. And I'll probably talk about these next class since we've run out of time tonight. And here's the library stuff. On the hub. That's where you can get all sorts of cool stuff. And in general, I'll say this, there's a ton of resources out there, but one of the learning objectives is to learn just how these artworks are created inside of video games. So that's why I reward you for doing your own artwork. Also, if you're going to go on for creating your own games, you want to make sure you're not using somebody else's, copyrighted art. You can actually lose a lot. You get sued if you're using somebody's artwork in a game that you're profiting from, and you can lose all of that, your profits. Okay, I've run out of time, but I'm going to stick around for a little bit more. So if you guys have questions, you want to just talk, you want to do office hours, you can do that. I'll be here for about another half hour or so. Yes, the book will help you with coding, and I'll walk through some of this stuff. Do you draw with a mouse? Yes, I do draw with a mouse. I don't have one of those fancy touch pads. Yes, I'm still working out hiring of the TA. You don't need an SSH key for the projects. You can do it without it. It helps if you're on campus and you have the campus VPN. You can use a SSH key that way. and it's a default message in Rieka in GitLab. Where did the chat go? Yes. All right. So good night, everyone. I'll stick around if you have questions, and I'll just be working on stuff. So let's see. What do we have to do for this assignment? So I'm going to start up Unity Hub. I've got Unity Hub going here. And I'm going to pull up my Rieka account. Yes, this stuff is root. And I'm going to create a new project. And where's my preamble here? So I can't see the chat room. If you guys have a question, just go ahead and just unmute yourself and ask. So I'm going to create my project, and it's going to be called